Hi everyone. In the given question of copy list with random pointer, a linked list of length is given such that each node contains an additional pointer which could point to any node in the list or null. So here, right, it's like a normal pointer, but unlike the normal pointer which is having the value of value and pointing to the next one, right, it has another value called random. So in order to do it right, the problem with solving it with a normal thing, right, is that let's say if I have initialized 7 and I'm getting a random pointer, right, which is pointing to null, it's fine. But let us take the example of, let's say, 11, right? Let's say I'm iterating from 7, 13, 11, but the 11 pointer is pointing to 1, but 1 is not yet initialized. So how is that going to work? So that is the bigger problem out here and we need to solve it. So in order to do that, right, we have to solve it using two passes. In the first pass, right, we are going to initialize all the nodes. So I will going to initialize 7, 13, 11, let's say 10, 1, right? And in the first pass, I have created those or added or initialized all the nodes, and I'm going to store that in a dictionary. You can store it anywhere, but let us, for the sake of it, let us store it in dictionary. In the second pass, what we're going to do, we are going to create the next pointer. Let's say 7 is pointing to 13, then 7 random is going to point to null value. Okay, null. So in our dictionary, right, we also have to give another value, which is like when we initialize our dictionary, right, it should have a value of none, which is pointing to none. Okay, so in case it's a null, it is going to be pointing to none value. Similarly, right, we have to, let's say we have gone from 17, right, we are getting 13, so 13 is pointing to 11, but at the same time, right, we are going to create another references of it to 7. Then we are at 11, so 11 is, I think, pointing to 1, but also 11 is pointing to 10. Then 10 is pointing back to 11. We have to do that. And 10 is pointing to 1. And 1 is again pointing back to 7, I guess, something like that. So you have to create that. So in the first pass, as I have told you, right, we are going to create the nodes and store it in dictionary. In the second pass, we are going to assign the next pointer and the random value to it. Although it might sound a little bit intuitive from the first, but I'm pretty sure if you see the code, it's everything is going to be cleared out. Now let us jump to the Python solution. The first thing that we're going to do, we are going to initialize our dictionary. So old to copy, and it would be none. So that in case, right, we are getting a null value, it is going to point to that. So none and none would be present. Once that is done, right, we are going to create a variable called cur, and we are going to point it to the head. While cur is present, right, while we have not iterated through the entire linked list. So in that case, we are going to create a copy variable and we are going to assign it with the node. So it would be node of cur.val. So you're creating the node, right, which is going to contain the value next and random. Initially, right, we have to pass in an integer according to, if you look into the class definition, how it's going to done. And once that is done, right, we have to do old to copy, and the value would be cur, and the value out here, ready key, would be cur, the value would be copy. And once that is done, we are going to say cur equal to cur dot next, and the iteration would be completed. Again, we are going to initialize another variable for the second pass where we are going to assign the value of head. So while cur, out there, we are going to say copy is going to be old to copy of cur, then copy dot next is going to be old to copy cur dot next and copy dot random equal to old to copy cur dot random. And again, because I have to iterate through it, so cur equal to cur dot next. So in this way, right, our entire copy would be created. Now let's say I have to return the head of the initial value. So it would be return old to copy. To how to get that, so it would be head. So in that case, you're going to get the value. Now if I run the code, as you could see, the public test cases got accepted. Let me submit it down. It passed very successfully and it is showing around 30.93, which is a little bit awkward. It should be, because you are taking big O of n time complexity, and the space complexity would be big O of n because you are going to store these values. Let me submit it again. It's 51 now. I'm pretty sure if I click on it again, it will be more than 80. It's not very accurate, but there is also another way of solving it, which is pretty intuitive. If I say, let me erase it down, but it's not a proper way of solving it. So just to show you, right, in Python, there is a function called deep copy. So you can do return deep copy of head. And if you run it down, and if I run it, as you could see, the public test cases passed. Means we don't have to do anything. We're just using a Python function to do that. Although it's not appropriate, but just showing you in case if you want to try it out. But obviously, right, if you're going to do a deep copy, the time would be a little bit lower. It wouldn't be that efficient, but anyway, just for the knowledge, you can check it out. That's all for this video. See you in the next one.